G'day guys, Alan here. Welcome back to the workshop. In this video I'm going to continue with the project I've started, a somewhat whimsical project, to turn a Briggs Stratton motor into an air compressor. And I explained what I was going to do, how I was going to go about it in the first video, and I'll put a link down below. And so my starting point is to make a valve plate to fit on top of the existing motor. And to do that I needed a piece of material, and in that previous video I started with that. Made a disc out of it, machined it both sides and the edge, and then moved the hole from the middle over to there. And now I've marked out on here how I want to cut out a piece to use as the valve plate. So that's what I'm going to do next, cut this out and start drilling some holes. Okay, so I've got it set up to hopefully cut along the dotted line. Just a couple of comments about the setup. The first is there are 6 clamps holding this piece down, and that's because I'm a bit paranoid about the cutter lifting the workpiece off the table, because when that happens it's ugly, you get broken teeth, and that happened to me relatively recently. So I don't know whether it's possible to have too many clamps holding something down, but I know it's possible to have not enough. Anyway, so I've got supports here, here and here, so these 2 clamps will hold the piece that's being cut off in place, and obviously there are supports under each of these 4, so it's clamped down as well as I can do it. This is a 150mm or 6-inch diameter wheel, cutting wheel, and it wasn't my first choice. I would rather actually have used something this size, but as I mentioned, I can't. Now this actually, even though the wheel is actually marked as a 1-inch bore, it actually is a 1 1/4-inch bore. I think a previous owner has actually machined it out, because even though it's this diameter, there's no keyway. So anyway, perhaps you can see there's a collar. So I machined a rebate or a shoulder on that. There's a very firm fit on the hole here. So now this thing is being held just by clamping pressure on each side. So that's a bit sketchy, but I'm hoping, because it's got very fine teeth and it's quite thin, that if I feed it in slowly, I should get away with being able to get the drive to the wheel just simply through friction here. Well, fingers crossed. I mean, cast iron isn't tough to cut. It's not like you're trying to do stainless steel or something. So yeah, well, let's get into it and hope for the best. Now, there's exactly what I was worried about. The frictional contact was not enough, so I have to back this out and see if I can get it any tighter. Okay, sorry for a bit of handheld action here, but perhaps you can see 2 things. The first thing is the marking on the disc I was talking about. As manufactured, it's a 1-inch bore, but someone's opened it out to 1 1/4. So that shiny bit is the arbor adapter I made, and you can't see very well, but I left the spigot that's come through the hole in the wheel too long, and it's now come flush pretty much with the disc, so that's why I've lost my clamping force. So I've popped the arbor adapter out, and you can see the little spigot there. So I've just got to just got to make that spigot a little bit shorter. Well, fortunately I still had the setup from when I machined this in the first place, up against my spider and all the rest of it. So it's going to be very easy to just whip off. I'm going to take 0.2 off, because this whole spigot is only 1.5 anyway. So I think 0.2 should be enough. Because obviously I want to leave as much of the spigot on there as I can. Yeah, I think you might even be able to see that there's a slight step there. I'm not sure how well the camera will pick that up, but anyway, so that should be all that I need to reinstate clamping force on the sandwiching on the blade instead of on the end of the spigot. So we'll whip this out and put it back in the horizontal mill. So I reset the saw and decided to finish the cut out at not at full depth. I was probably at about 3/4 depth, I suppose, something like that. Anyway, I just thought that would lighten the load on the saw a little bit and reduce the likelihood of it slipping on the arbor. Well, I think that's close enough to out that side, so we'll run it back and come back at full depth. Alright, so, yep, all the way through. So now I can remove this bit. That was more drama than I was hoping for, but on the plus side, nothing got damaged or broken. It's just a shame the keyway was taken out of this wheel. Anyway, there we go. Useful bit of scrap perhaps. So now I have to decide whether the pain of using that is worth it for cutting these two sides off. The alternative, of course, is to go over to the other milling machine and just mill the pieces off. But this stuff makes a hell of a mess, so I would really rather slice it off. Let's have a look. Well, I guess one question for a start is if I do turn it round at 90 degrees, can I cut both pieces off with one setup? Yeah, let's give it a try. So, since there seemed to be quite a little bit of side friction between the slitting saw and the work, I thought it'd be a good idea just to check that the table travel is in fact still parallel to the, or perpendicular, well, at 90 degrees to the milling spindle. And that's pretty good. I'm not going to try and improve on that. That dial gauge is reading 0.01 of a millimetre. Okay, so now we use the dial gauge to set this edge that I've just cut to be parallel to the milling arbor. Alright, well that seems to be pretty good over the length of the cut, although it does wander off a little bit in the middle, which perhaps is a clue to why the slitting saw was grumbling a bit. But as far as setting it parallel to the milling arbor, I'm going to call that good enough. There's one side trimmed off. I should have probably said this is just rough trimming to give me a block that I can work with. That's why I haven't been too fussed about exactly where I'm cutting. I'll be doing other trimming much later. Oh, so that's the other end locked off. Okay, so I think now it's time to take it out of this milling machine and do some detailed marking up, and then put it in the other milling machine to drill some holes and get on to the next stage. Okay, so I've removed the stock from the milling machine and brought it over here to the bench, and the idea now is going to be to use a transfer punch to mark the hole positions. As you can see, I've clamped the cylinder head to my plate, the stock, because I use the gasket for marking the holes out, but I would rather use the cylinder head itself to mark the hole positions. So the holes here are 8.5mm diameter, but my plan is to drill 8mm holes and give myself a little bit of leeway if I need it to line things up a bit. So I'm going to start, but I'll mark all of the holes, but I'll start by drilling the two diagonally opposite ones, I think, and see how that looks. And of course now I've got the 3 square sides, or 3 straight sides and 2 right angles. It's easier to get some repeatable putting the thing back into the vise. Okay, so let's get on with it. First hole. It's a good start. Punch doesn't want to fit in that one. Well, let's take the ones we can get. Well, it's encouraging to see that the hole markings seem to line up pretty well with the marks that I made from the head gasket. The solid black dots mark the position which I'm going to need holes for this thing, but they're going to be a different size hole, and I'll do them in round 2 because there's one common hole, so I'll be locating these others from that common hole. So in fact, actually, I'm wondering whether I should drill that one down to the smaller size to start with. I think that might be a smart move. So what is that smaller hole size? About an H size drill. So I might mark that now. H. All the rest of them are 8. Okay, now going over to the milling machine. Okay, it's raining, so apologies for that, but anyway, time to drill some holes. So I want to be able to take this out and put it back in the vise again and find the hole positions again. So I use this little widget to find that corner and set that to 0, 0. So I'm going to mark that on this chart of the object. That's our 0 over here. So this first hole, I'm using this centre finder, and so I'm right on it there, close enough. So I'll record the position of that as X is minus 15.42 and Y is 10.11. And do the same with all the other holes, so that I'll be able to put this back in and then find all those holes again. And that's particularly useful because this guy over here I'm going to initially drill it as an H hole, but I'll have to come along afterwards and do it out to 8. But I'm going to do all of the holes at 8mm, which may not be big enough. Anyway, for all those reasons, I'm going to make sure I can find the holes again afterwards. So I'll bring you back when I've finished doing that. Okay, on to drilling some holes. Now I've got a little jack under here just to make sure nothing untoward happens. So I'm going to go around and do a pilot drill hole first. I think I'll do the H first. So these holes are pretty close for these bolts. There really isn't much room to move. But if the hole pattern isn't quite right, I've got a little bit of wiggle room with an end mill to fix it up. Anyway, we'll take this out and see if it fits on the block. The big moment. One line's up. Huh. I've got it on the wrong way around. Which way around is it supposed to go? Sure, now which way around it's supposed to go? Let's try that. Yeah, that looks a bit better. I won't be able to do it up all the way anyway because of the exhaust valves getting in the way. Well, not only do they all fit, I drilled them at the absolute minimum size, and they still move on the bolts. So that's pretty damn good. So obviously using the transfer punches worked out pretty well. Very happy with that. Okay, so in my excitement to see that all of these bolts fitted, I was forgetting that the ones which are going to be underneath this thing will be countersunk screws, so that the other bit can sit over the top. That's why I've got these other holes marked here. So yes, that's the other reason why I wanted to know exactly where the holes were, so I could do the countersink. Anyway, on to the next bit. Okay, so we've established that the bolt pattern matches the cylinder block, which is really good. Next bit now is to work out how to fit this piece on. Now, as you can see, if you have a look, we've got, perhaps you better see, these black dots here. I can get one hole lined up with the cylinder block, the original holes, but the other three don't. And because this piece has to sit on top, clearly, if I have bolts, for example, there, then I'm in trouble. So what I've decided to do after a bit of a head scratch is try, I don't know whether this is going to work, but I can give it a try. This was a bit of scrap that I chopped off, of course, and you might see that I've bored it out 10mm to 10mm and left a 3mm thick piece at the bottom. And I've made a special bolt, turned the head down, made the head skinnier, and that will now fit in there. And so I'm thinking about applying that to these, to the three black holes here. 3 black holes, yeah, anyway. So let's explore this idea a bit further. Okay, because I've reduced the turn material off the outside of the screw and weakened the wall, I wanted to test it to make sure it would still be suitable for my project. So the tightening torque for my job is 140 inch-pounds, so I've set the torque wrench to its maximum of 250 inch-pounds. You can see it's not having any trouble with that, so I don't think I'm going to have any issues with the failures of the head just because I've made it weaker. So another aspect to this slimming the head of the bolt down that is a potential problem area is whether or not there'll be enough material in the bottom of the hole to resist the force of the screw being tightened up. You can see there's really quite a small land there, so I want to make sure that the screw won't pull the bottom out of the hole. That land is about 3mm thick but only about 1mm wide, 1 and a bit millimeters wide. So I've got a crude test here to try and satisfy myself on this point. And put that on. And that on, and we'll see how we go. So what I'm worried about is that the tapped holes in the top of the cylinder block that this will screw into have a relief around them that's about equal to the size of the hole here. So that means that bottom lip that I've got here is going to be unsupported underneath. So I want to make sure that this will actually take 140 inch-pounds. So let's see how we go with 140. Well, it's tolerated 140 all right. Let's have a look. That seems to be all right. The screw's embedded itself a little bit. Okay, so probably a more demanding test is the relief around the top of the holes in the cylinder block is actually 8mm, and this is a 9mm hole. So if I put that under there, you can see how there's more material unsupported. So let's see how that works. It can be something like that, I guess. Not extremely scientific. Alright, so we're still set on 140. See how we go. This thing doesn't work very well. I cut it off the end of an Allen key and one end isn't quite the right dimension. Anyway, it's getting the job done. Alright. It's my 140. Let's examine that. Doesn't seem to have caused any breakout, so I'm starting to feel quite comfortable about this now. I mean, who knows how it's actually going to work out. I can only do sort of reasonable checks along the way. So anyway, I think that's good enough for me to carry on. So I'm going to make another full set of these screws now. This is the setup I use for slimming down the heads of the cap screws. I take 1.5mm off the bottom, just under 2mm off the diameter, and a little bit off the top. This is pretty hard stuff. It's 40 Rockwell, so yeah. So I switched to my other setup now to face these caps to length. I'm wanting 6mm. The exact length, of course, well, the exact length isn't critical, but 6 would be good. So I've got to take about 0.5mm off. No, I guess that's close enough. Okay, so now I want to do counterbores in 4 of these holes for my special screws. Now, because I recorded the coordinates of these holes when the plate was last in here, it was easy to put it back in and get set to the correct position. So these counterbores have got to be 6mm deep. That should be 5.8. Now one of these, the first screw I did, this the cap is a little bit shorter, so it doesn't need quite the same depth of counterbore. Alright, let's see how this one looks. Yes, I'm not sure how much deeper it will be pulled into the hole when it's done up tight, so I'll sort of check that. That's actually about perfect, because I don't really want the screw to be lower than it needs to be, so I think we'll call that one good at 5.8. The others I think probably do need to be the full 6. Well, I might as well leave that in there and then get confused. And I can see that one's going to pull up just fine. Let's put this back down, just to make it easy to bring this back to its spot. And then we'll, I was just going to take it out and go and try it, make sure that the 4 bolts and everything does fit. Then we'll come back and do this pattern. But I want to make sure it fits before I do that. Fingers crossed. Okay, as perhaps you'll be able to see, everything seems to line up. We're pretty happy about that. I haven't done anything up tight because I've got the original gasket under there at the moment, the original head gasket, and the reason for that is the valve heads stick up a little bit above the block surface, so until I rip the valves out I can't, I've got to have the thickness of the gasket there. Okay, so you can see this bit's going to sit on there now, so this bolt will be taken care of with one that goes through, and this piece as well, of course. Decision for me now is whether to drill right through this for those 3 holes, and then use bolts with Loctite as a thread sealant, and I'm leaning that way. The alternative, which is to drill blind holes and tap them, I hate hate drilling and tapping blind holes. It's just so easy to screw things up, and I don't think I really gain a hole heap by doing that, so I'm thinking that's probably what I'll do. So I'll tap this one, drill and sort this one out first to give me a location, and then on with the others. Right, progress. Okay, well, a bit of progress. So the top goes on, all the bolts sort of line up to be put in. So that's all good. And the 2 sort of purchase valve plates with the what do you call it, the shim in between. I haven't got the reeds in at this point. There's no reason to do that, and I haven't cut the holes in the top plate here yet either. But anyway, you can see how this is all going to go together. I've got to decide what to do with gaskets as well. Gaskets between this stack and that, and at the moment I've got the original head gasket in place underneath that to make sure there's enough room for the tops of the valves. I think I mentioned that. But I think that's all looking pretty encouraging. starting to look like it might work. So I've got to stop and think now about which bits to do next. I could trim some of this these corners off. That might be a good thing to do since I've finished the machining on the plate. Oh, well actually no, I haven't. I'll leave the plate as it is because I haven't decided yet whether to use both of these and have the that shim thing, or the reed sandwich between these two plates, or whether to only use one and cut reliefs in here and use this and this as the sandwich. I've got to think about that one a bit more. I might well, I'll just show you. I think you can see there's the plate would need to have a valve pocket like that machined into it. And I have to do a dummy run on some scrap material to see how easy it is to achieve this feature, because it's been cast in, not machined, and as a result it's got a shape which I don't know that would be that easy to achieve with manual machining. It looks like you could use a large diameter rotary cutter, but the it doesn't come up to the surface here. There's a step down, so I don't know for the moment how to do that. I'm thinking I'll map it out and see whether I can achieve a similar result with straight lines, because I'm not sure whether it actually needs to have that curved shape. Anyway, that's very much the next thing to sort out. Yeah, okay, well I'm going to end this video here. I've got to go into think mode again now. Got to think about the valve plate and the sandwich thing, but I also have to work out how to build something to fit over the top here and attach some pipe work to. But it's encouraging. It looks like it's going to be doable. So anyway, thanks for watching, and hope you'll join me when I get back into it again and I've got some more progress to show. Cheers.